Okay. Now you can see here in this technique, which is vector field f integral, okay, we are given vector, which is f of xi, fyj, fzk. So this is vector. And dr is the same in the previous technique, which is scalar vector, scalar field. Dxi, dyj, dzk. Integration of the multiplication of the two will give me at the end scalar. You remember last time we come up with vector or scalar? Anybody remember? This is the last time. As you remember here, I, j, k. So it's vector. Now in this one we will come up with scalar. Why? Because we have vector here and vector here. So and dot product between them, dot product of vectors will give scalar. You may ask about the application for this. Application, it have wide range of application in the life and industry. As example, the speed and direction of moving fluid through space, strength and direction of some forces, and so on. Magnetic and gravitational force and effect of them on, let me say, body or anything inside these fields. So it have many applications. Now, how we work using this method? Have a look. I will start with example and then you will solve exercise. I will support you. Now you are given a vector f. This is the vector f. As you can see, I, j, k. And he asks you to integrate. See the circle here, C? What does it mean? We discussed this last session. We integrate across among curve. And then you are given 2 points A and B, and these 2 points for the curve x given, y given, z given, all of them function of time. So it's a procedure. We follow the procedure. Have a look. Now this is f given to me, x square. Where is x? This is x. It will be 4t square. You see I'm using brackets. Work in steps, don't jump. Then y is 2t square. I put it in a bracket. Then I plus x 4t. I put it in brackets. Then z t to the power 3 minus 2 y, which is 2t square, z t3 to the power 3. And then next I make sure do math. I know it is easy, but make sure to do the correct multiplication, addition, the power. Make sure you do them correctly. Any mistakes here, it will be accumulated. Now, as you can see, f now became function of t only. There is no x, no y, no z. The same thing we could do for dr. I will differentiate x and y and z. Dx is 4t dt directly. Dy is 2t dt. Dz is 3t squared dt. Now also dr became function of t only. There is no x, no y, no z. Next is the point A and B. Okay. You see here A and B. I will back to this point. A and B. This is x. This is y. This is z. Now x is 4t. So 4t equals 0. Y is 2t squared equals 0. Z is t to the power 3 equals 0. The only solution for these three equations is when t equals 0. It satisfies the three equations. The same thing for B, x, y, z. It take one of them. X is 40, so 40 equal 4. So t is supposed to be 1. So the equation will be correct. I got it. Then according to the formula, f dot dr. Let me do dot product. Have a look. Have a look. This is f as we got it. And this is y. You know dot product, it means multiply I element plus j elements plus k elements. So this element will be multiplied by this element. I'll go the first one plus this element multiply by j elements for the other vector. Mute your mic, please. Next is this element, which is k element, multiplied by this element, as you can see here. You see, make sure to take the signs. Okay. Now we multiply power. We know how we deal with indices, and this is what we got. Next is I will apply integration. See, I apply the integration, but now not from a to b, from, you see, this is the original, from t0 and t equal 1. The remaining is very easy, direct integration. You see here t to the power 4 will be to the power 5 over 5. Here t to the power 6 over 6, t to the power 8 over 8. Simplify and substitute for 1. We got scalar value. It's a procedure. Let me back to the question. Have a look here. We may change the point. We may change a and b. We may change the curve points x and y, z. We may change the vector, but the steps are the same. The procedure is the same. You can see here, we started converting x, y, z into t. The same thing for dr, for the vector and dr, and then we do dot product, and then we convert the points a and b into t, and then we do the integration. The same steps. This is exercise. I change the values here, the elements here, and I change the points plus the curve. Can you solve it? Okay, you start solve it. I give you 5 minutes to solve, and then we will work together. Start solving.
Doctor, I have a question.
Yeah, please.
In the beginning, you said that the answer would be vector, but here we got the answer as scalar.
No, not this one. Not this one. Have a look. Have a look. Not this one. The previous one is vector. You see here, the previous one, when we started with a scalar, this is vector field. Scalar field give me vector. But vector field give me scalar. Why? Because you see here, have a look. You see here, what we have? Vector dot vector. It means dot product. You remember from level 1, semester 1? Dot product give me scalar. Right? So don't confuse between them. We have two techniques. Scalar line integral, scalar field line integral, and vector field line integral. For scalar field line integral, you are given scalar, you do the integration, you come up with vector. For vector field line integral, you are given vector, you do integration, you come up with a scalar. So back here, please try to solve this on a paper, piece of paper. Organize or manage your work. Don't jump, use brackets, don't forget signs, do the mathematical calculation correctly. In tutorial, you will solve more problems related to these topics. More problems, more practicing with your misses in the tutorial session.
Doctor, please, your mic is mute.
Sorry. Okay, I will convert the vector f. Thank you. The vector f from function of x, y, z into function of t using the curve points. Have a look. Now x will be converted into t. Y square, I put it here, t 2t square, all together square I, minus again y times z. Z is given here 3t to the power 3j plus 3t square times z. Z is 3t. Did I forget anything?
Yes, square.
Excellent. I forget square. You see here? I lose the question. It's a procedure. It's a procedure. You forget any number, any sign, you lose the question because it will be accumulated. Okay. Now I simplify.
3, not 2.
Sorry? You see? Yeah, I know it's the 3. Okay. You forget any number. You write any number. You see, I'm working on the same page. I forget 3. I wrote it 2. So these type of mistakes, what happen in final exam, these type of mistakes. On the same page, you copy incorrectly, you do wrong, let me say, calculations and so on. So make sure you do this correctly. Have a look. Here, K, definitely. Now, square, it will be for t square and for 2. So it will be 4 t to the power 4 plus 1 t to the power 5. Please follow me. I may get some mistakes here. Follow me and correct me. Minus 2 times 3, 6 t to the power 5j plus 3 by 9 t to the power 5k. Did I forget anything? Is there any mistakes here in the calculations?
9t power 6.
9 t power 6. Why power 6? T to power 6. We add them, right? 2 plus 3, 5, right? Okay?
Yeah.
Okay. Yeah, okay. Now I come to dr. You know, dr is dxi plus dxj plus dxk, right? Now I will come to x. X is t, so it will be only dti plus y is 2t squared. It will be 2. It will be 4. Sorry, 4t dt j plus k. Z is 3t to the power 3. It will be 9t squared dt k. Now I have both. Next, I will change the point here, A and B, from points with respect to x, y, z into point with respect to t. So I will say yes.
The sign is minus, not positive. dti minus.
Which one you mean in dr?
Yes. dti minus, not plus.
dti minus 4, you mean?
Yes, minus 4.
From where it came, the minus?
From the formula above.
Which formula? This is the formula. Let's say positive. Right?
But if equal xy square I minus yz.
Okay, let me take you back. Take you back. You see, this is the formula in the method. You see positive here and positive here?
Yes.
It's correct. Okay. Now next is I apply. I go for A and B. For A, okay, you can see x is 0, y is 0, z is 0. I will take one of them. 0 equal, where is x? X is t So this directly gave me t is 0. For b, x is 1. As you can see here, 1. I substitute here by 1, it gives me t equal 1. So I got both of them directly. Next, I will substitute, rather than its function of a, b, f, and dr function of x, y, z, I will substitute in this way. Integration from t equal 0 to t equal 1. F, where is f? Just a minute, let me see f. This is f. Okay. I will come here to say, okay. By the way, this is vector, and this is here vector. Okay. So dot product of two vector will give me scalar. I element, we multiply them, plus j element, we multiply them, plus k element, we multiply them. So I element is this one. I come here to say, okay, 4 t to the power 5 multiply, okay, let me say it this way, multiply by dt plus, what else? J element is this part, 6 t to the power 5, and this part, sorry, this part 4 dt. Did I forget anything here? What do you think?
9.
Excellent. I forget the minus. Put excellent. Plus. Now next, 9, 5, sorry, t to the power 5 by this part. 9 t square dt. Okay.
Doctor.
Yes.
4t dt.
4t dt. Which one? The first element or the second or the third? Second. Okay. You see, I forget t. Excellent. Thank you very much. You see, just copying from the previous step, I forget t. So this is what happened. You know the procedure, the method is clear for you, but you forget items because there are many. Make sure you copy correctly. Now you see here, dt is in all of them. I will take it as a common outside. It will be dt here. No need for this. Simplify more. Please try to do it now. And tell me who got this value. Or let me say in decimal point. Check it. Check it. Do the integration and tell me what you got. Is it the same? Who got the final answer?
Doctor, I have a question.
Yeah, please.
The point of A and B, it's always 0 and 1?
No, not always. It depends the numbers. But here I try to make it easy. Directly we got it. I mean, simple numbers. 0 and 1 are the simplest numbers. For that, the example is coming with 0 and 1. But doesn't necessary to come as 0 and number and 1.
Okay.
Doctor, it will be 7.36.
It's in fracture with me. Okay, check it. Check. Let me check it by calculator here. 1 second. 6 times. Sorry. 7 times 61 divided by 168 equal 2.54. Correct?
I get 2.6.
It's okay. It's almost the same. Just approximation. Any more? You got the final answer? with more practicing, this will be more easy. In tutorial, you are going to practice, okay, in your session. The next topic next week will be matrices. It will be more, let me say, interesting topic. We will work maybe for 4 or 5 weeks. It's really interesting, and you will use it a lot in your study in engineering, especially in level 3 and 4. Nobody else? Only one?
I got, doctor.
Thank you very much. Who else?
I got, doctor.
Great, great, great. Great, thank you very much. So almost most of you, they found it. Yes, you got it. Great, great.
Yes.
Now last point to close this session is the green theorem. You remember until now we are doing integration across among curve. Okay, we are giving curve C and we integrate among it. In some applications, the curve is closed, become a closed area. Okay, it's curve, so like this one, but it get closed. When it get closed, we have to use green theorem. Green theorem apply when we do line integral across the curve in a closed boundary region, or let me say closed curve. Okay, for that you can see the formula here, formula which used by green theorem. In green theorem, integration curve C, but they make a circle on the integration to say that this integration for the curve in a closed region. Okay, mute your mic, please. Abdulaziz, mute your mic. Okay, thank you. Now, see the formula. See the formula, what it say. F dx. By the way, f is function of x and y. But we will differentiate with respect, integrate with respect to x only. So y will be constant. Plus g, the second function, integrated with respect to y. So x keeps constant. Okay, this is the formula. How we do it? By using what we call a double integral. It means integrate it twice. How we integrate twice? Have a look. Partial g over partial x. We took the second function, the function of dy. We differentiate it partially with respect to x, minus partial f over partial y. We took the phase function. We differentiate it with respect to y. So we keep x as a constant. Now the expression here will be integrated first with respect to x, and then we integrate with respect to y. This is the formula given to you. How we use it, I will give example here and more examples or exercises to come in tutorial. Have a look. He told me evaluate the line integral over a triangular curve. You see, it's a closed curve with vertices 0, 0, 1, 0, 1, 1, oriented in this way. Okay, this is the original. Okay, and this is 1, 1. So he told me to find the integration for this curve given the order. And this is the function he gave you directly. You see, integration circle C, and this is y dx minus x dy. Directly I remember. See the formula. The formula say f dx plus g dy, right? You remember this is the formula. Okay. Now let me see. F is y here, and g is minus x here, right? Now what the formula say? Just let me remember. Double integration partial g over partial x or y, x, minus partial f over partial y dx dy. So let me do it. Double integration partial g. What is g? Is minus x. So minus x differentiated with respect to x is minus 1. So minus 1. Okay, minus. Partial f is y. Differentiate with respect to y. Partial y over partial y is 1. So here is 1. Minus 1 is minus 2. It's constant. I put it outside. Minus 2, as you can see here. You see here? This is what I did. It's minus 2. Now next I do the integration. Integration minus 2, I take it outside. Integration of dx is of dy is y. You may say, can I integrate first with respect to y and then with respect to yes, we can. Can we integrate with respect to x and then with respect to, yeah, we can. Have a look. We integrate with respect to y, it will be 1, y. Substitute from 1 to 0, you got 1. So 1 here. Integrate with respect to x, dx mean integration dx, it will give x. Substitute from 1 to 0, it will be 1. Multiplied by the outside constant, which is minus 2. This is the green theorem. Now, more examples to come. It's easy, direct. Just we need to know the formula here, and we apply it. We substitute and apply it. Now, let me summarize the topic. Topic number 1. In topic number 1, we discussed vector calculus, and we understand from level 1 semester 1 that vector the calculus is the main part of calculus are differentiation and integration. We know how to apply it on scalar, but what about vector? This is our discussion in this semester. We started from revision for the vector properties, products, dot product, cross product, their applications, addition, subtraction, multiplying vector by vector or vector by scalar. And then we started our topic with differentiation, then we moved to integration. For differentiation, we define the del operator. We use it to find the gradient, and then you use it to find a directional derivative of a scalar in the direction of vector. After that, we learn how to use it to find, for a scalar, to find unit normal vector. And then we use it for div, which is dot product operation, diff of vector, mean divergence of vector, and curl, which is convergence of vector, which is cross product. When we completed the differentiation, we moved to the integration. We started with the scalar integration, okay? Scalar field line integral, where we are given a scalar, we integrate it, we come up with vector. After that, today, we started with vector field line integral. We are given vector, we integrate, we come up with a scalar. And finally is the green theorem, where we are given curve, we want to integrate among the curve, but this curve is closed circuit. So we have to use double integration. Okay, this is simple compare with the previous two techniques. I will stop here. Do you have any question? Do you have any question?
I have a question.
Yeah, Kauthar, please.
For this question, like for this
Yeah.
example, how did you know that we have to take the point 1 to 0?
For 1, 0, this is the origin. This is the origin. Take it as a closed circle. Okay, this is the origin here. Take the from x 0 here, and the last point is 1, 1. So you take from the first one and the last one, 0 to 1. With more examples, with the misses, you will learn how to substitute. Any more questions? Okay, I will stop here. We will continue with matrices next session, inshallah, next week. Have a nice weekend. Have a nice day. See you. Bye-bye.